Okay, so this is the KE graph for an oscillation. If its maximum KE is reduced by 40 millijoules, what would be its new amplitude? So many students correctly got the idea that it has something to do with 75 minus 40 millijoules, and so they get this number 35. Unfortunately, what many students do with this number is to read off this original graph at 35 millijoules, and they get a wrong answer of 1.75. So we got to think through it carefully, how the KE graph would change if its maximum KE is reduced by 40 millijoules. So this is the original KE graph. We know that it's going to lose 40 millijoules of KE. So if its maximum KE used to be 75, the new maximum KE ought to be 35. So basically you got to shift this graph down by 40 millijoules so that the maximum KE is now at 35 instead of 75. So the entire graph is shifted down by 40 millijoules, and you can read off the where the graph cuts the x-axis here, and there you get your amplitude, which turns out to be about 1.65, about 1.65. So actually, if you want to read off the new amplitude, what you should have done is to read it off at 40 millijoules. Then you will have arrived at the correct answer. I hope the reasoning is clear to you now, because at this displacement, the KE used to be 40 millijoules, but you have lost 40 millijoules of energy. So at this displacement, your KE is going to be 0 now. So the points where KE is 0 is the extreme position, so that's the amplitude of the oscillation. By the way, this question asked you to show your construction. By that, I guess they want you to construct the new KE graph. So what you do is simply to shift the original graph down by 40 millijoules. So you probably pick a few landmarks, and just drop it by 40 millijoules. And then you just join all those points in a smooth quadratic curve. Okay, I hope I've made it clear. Ta-ta!